changing magnetic field can create currents, and currents can create magnetic fields, so we can create a changing magnetic field by turning on or off currents or by moving a magnet. So I'm going to use 2 coils now, and I have 4 banana to spade connectors. So our Hamden power supply is going to be hooked up to one of our coils. It's off while I work on it. I want to make sure that I leave that hole in the middle of that coil accessible. And then our other coil, which has many turns of a very fine wire, is going to be hooked up to our sensitive current meter. Hooking the spade ends up, and the banana plugs up. Once everything is connected, then I'll turn this on, be on the finest scale, and turn that on. Then I'll turn the Hamden on, and I'm going to run just an amp through this coil. So we've got an amp going through there. If you ever notice this coil warming up, turn it down, turn it off, call your TA. Running an amp through there, and then sliding that into our other coil and out. And so you can see the effect. We've got current moving through this coil. When we move in or out, leaving it in there doesn't do anything. Now, there's no path for the electricity to make it from here to here. It's not that the Hamden is driving a current through this directly. This is induction. We can also try turning the Hamden off and turning the Hamden back on and seeing the effect of the current. Now, if the effect is too large and the needle is in danger of exceeding the scale, you can go to a less sensitive scale and then try again, where you can see the entire range of motion. And on that finer scale, we have 2 different rods, one of iron, one of aluminum. Try sliding that rod in and see what effect that has, moving it out, or moving the coil with the rod out and in. And then try the same thing with the aluminum rod. Investigate what type of pickup you get from this coil driving a current through this coil with the Hamden. When you're done, turn everything off,